Alright, let's get this done. Time for the last two. This is all solving equalities or inequalities with absolute value. When dealing with these, try to get your equations so you just have your absolute values stuff equals number before you try to split it into two equations. So let's get rid of this 2 here by subtracting 2 from both sides. And now we got 3 times the absolute value of 7 plus 3x equals 6. And I want to get rid of the 3, so I'll divide by 3 on both sides. And now I'm at 7 plus 3x equals 2. Oh, absolute value. I forgot about that. Don't forget about those. Alright, now I can split it into my two equations because I got absolute value equals number. You're going to write your equation exactly how it is without the absolute value. Why did I all of a sudden decide to write 2? I don't know. But I did. It's supposed to be 3 equals 2. So you write it once exactly how it is, and then you write it one more time without the absolute value and with the number being negative. Because remember, you can put inside the absolute value either the positive version or the negative version, and it will still give you 2 because when you take the absolute value, it makes it positive. So now I'm just going to solve these. I'm going to do exactly the same steps, by the way. But remember, they are different equations, and so be careful that you don't think you get. Be careful that you don't just get the same answer twice. Because positive 2 minus 7 and negative 2 minus 7 give you different results. So now I divide by the 3, divide by 3, divide by 3, divide by 3. And on the left side, you get x equals negative 5/3. On the right side, you have, I'm going to write it up top here, x equals negative 9 divided by 3 is negative 3. Ta-da. So x equals negative 5/3 and x equals negative 3. That's it for that one. And we'll move on to the inequality one, because these are always oodles of fun. Once again, I want to get absolute value is less than number without this 8 and without the number in front. So I'm going to subtract 8 from both sides and to get to absolute value x plus 5 less than 2. Divide by 2 to get my absolute value by itself. And now that's less than 1. Now at this point I can split it into two inequalities. One of them is x plus 5 less than 1, and the other one will be x plus 5 greater than negative 1. Remember, on your two equations, one of them is just like how it is written originally, and the other one, you change the direction of the sign, and you make the number negative. It's kind of a complicated process, but that's how it goes. And we only got one step to solve these ones. I made that surprisingly easy. Shame on me. Yeah, you subtract 5 to get x by itself. And so we got x greater than negative 6. Okay, so whenever you start with a less than guy, you have an and compound inequality. So if I were to graph this guy, I made that really low at the bottom of my screen, so I'm going to have to erase it and draw a little bit higher so I can actually put numbers on it. There, I'll make it that high. Okay, I'm dealing with negative 4 and negative 6 as my answers here, so I should probably put 0 over here. There's negative 4. And put negative 6 there, negative 7. Here, negative 2. You know, put some numbers down so you know what the tick marks stand for. I'm going to graph my left one first, where x is less than negative 4. It's open circle because there's no line here. And it's shade left. Bam, shade left. I'm going to graph my right one. The point of interest is negative 6. I'm going to put it open circle because there's no line. And I shade right. Shade right. Okay. Since it's an and compound inequality. Remember, whenever you have your absolute value is less than, it's an AND compound inequality. We're only interested in the part of the graph that got shaded twice, which is between -6 and 4. And so to write that in interval notation, it's -6, comma, -4. And it's round brackets because they're open circles. Ta-da! All done.